Okay, since we're going to talk about solving for x, and I'm going to show you the traditional method on the left side, and then my method on the right side, so you can see the difference. You see that when you use my method, you'll have less chance for error. I'll go through a couple problems. Here's the first one, okay? And I'm going to point out the errors along the way in the traditional method that occur. All right, so let's start with some basic vocabulary here. When I have a number by itself, these two right here, those are called constants, okay? The number in front of the variable, it includes the sign as well, so -3, that's called the coefficient. Every variable has a coefficient. If you don't see a coefficient, it's 1. But every variable, or if it was -x, that's -1, okay? So every variable has a coefficient. So in the traditional method, they would just have you keep this -3x on this side, and so they would say, go ahead and subtract, we're solving equations, reverse PEMDAS. Okay, add or subtract across. When you add or subtract across, it's entire terms. Okay, remember terms are separated by plus or minus signs. So this is one term, this is one term, and that's one term. So you have 3 terms in this equation. It's called an equation because it's got an equal sign. Remember the left side of the equal sign is called an expression, and so is the right side. This is an expression. So 2 expressions set equal each other are called an equation. Now I can add one more word onto the left side of the expression here. I can add in, I'll just put it on the bottom of it, algebraic expression. Okay, whenever you hear the word algebraic expression, when you hear algebraic, you know there's a variable in that. That's what algebraic means. It's got a variable inside of it. So notice on the right side equal sign, we would not call it an algebraic expression because it only has a constant term. So that's just an expression. You can also call it a constant term, but you would not call it algebraic because it does not have a variable. Okay, so that's some basic vocab. I'm just going to take that off so we can now work the problem. Okay, so the traditional method, it would have you go ahead and subtract 14 across. Okay, so the first error that may occur is when you bring this down, people only bring down a 3x and they forget the negative sign. Second error that can occur, some people forget how to add integers for the like terms. And so they come up with -7, +7, +21, etc. You need to remember that when you add like signs, you add the numbers and keep the same sign. So it's -21. Okay, the next thing that is a chance for error is now you're at multiply and divide, so you're dividing by the coefficient of x to get down to 1. And divided by itself is 1, so I need to divide by -3. Well, a common error is they forget to bring down the negative sign. So there's another chance for error right there. Okay, so now I have +1x, and then some people, even if they see it written like this, they ignore the negative in the denominator and they will write -7 for their answer. They forget about that negative down there. Or they leave it as -21 over -3. Okay, but more likely it's when they go ahead and forget the negative down here and just have -7 for their answer, and then they get it wrong. Okay, so you also have to now remember a negative of a negative is a positive, and 21 divided by 3 is 7. So those are all the common potential errors. Now look, when you do it my way, that none of these basically occur. Okay, so my method is you look at the coefficient of the x or the variable that you're solving for. If there's more than one variable, if there's an x and a y in it, and you're solving for y, you look at the coefficient of y. Whatever variable you're solving for, you look at the coefficient of that variable. If it is negative, as it is here, you're going to move it to the other side to make it positive. So the variables are going to the right, which means the constant is coming across the left. So that means I'm going to add 7 to move the constant across. Remember, we do the opposite operation. I'm moving an entire term across, and I'm adding 3x to both sides. Okay, so now look what you get. That cancels out, and you get 3x and 14 plus 7. Everybody knows that from elementary school. 21. You're not even dealing with negatives at all. And lastly, you're just dividing by positive 3, so you don't have to remember to bring down that negative sign like you had to do over there. You don't have to remember that a negative by negative is positive because you're dividing two positives here. So the answer is 7. You know that from third grade, 21 divided by 3. So you can see completely the same answer. If you do all the right steps, you're going to get the same answer. But you see how I teach it, that there's way less chance for error with all the negative signs that are left on the left side here and not on the right side. Okay, you can do it either way. You're still going to get the right answer as you see if you do all the correct steps. Okay, it's just one has a lot less chance for error. Okay, let's look at one more problem with inequalities now. Okay. Now, like I said, I think I said it in the first time. If not, I want to clarify. When I say this is the Carlsen method, there's plenty of good math teachers that do this. So don't think I came up with this or anything like that at all. It's been around before me. Now in factoring, we get to second semester, I do have my own method that I haven't seen or hadn't seen until years later after I had done it on YouTube, but this is not. Okay, so let's look at a similar type of problem. Let's say we have 10 minus 5x is less than negative 15. Okay. So I want to solve that inequality. Let's write it down again over here. Okay, and of course we solve all equations with reverse PEMDAS, reverse order of operations, as it's called. Okay. So again, traditional, let's say go ahead and leave it here and subtract the 10 across because we're doing adding and subtracting, so we're moving an entire term across. So they're keeping their variable on the left side, the constant's going to the right. Okay, so I have, again, they could forget to bring down the negative here. Some people forget negative stays negative and you just add the numbers. Some people subtract the numbers, okay, because they forget their integer rules. So again, potential chance for error. Now again, like I said, I'm dividing by negative in this case. Some people forget to bring that negative 5 down. They write down positive 5. So that's another chance for error. So you think it's exactly like the last one. Well, you're showing me the same errors. Well, that part's true, but there's another additional part of an error here. When you have an inequality and you divide or multiply by a negative, you must remember now to switch that inequality. So this adds another error onto it when you do it this way. So yes, you get 1x, but now you have to remember to switch the inequality sign. And you have to remember a negative over negative is a positive. You can't forget this negative down here and put negative 5. You have to remember negative over negative is positive. Okay, so this is the correct answer. But now you're having to remember to switch the inequality sign on top of the other basic errors. Now let's see, doing it how I teach it. Again, I look at the variable I'm solving for is x. I look at that coefficient. It's negative. So I'm going to move it to the other side. The coefficient, the variables are going to the right, which means the constant is coming over here to the left. So the opposite of negative 15 is plus 15. Line it up under like terms. Okay, gonna add the 5x across. And then that cancels out, and I get 5x is greater than 10 plus 15 is 25. And now last step, divide by 5. I don't have to remember to bring down a negative sign at all. I don't have to remember that a negative by a negative is a positive. Okay. And because I'm dividing by a positive, I don't have to switch the inequality sign. It already did that for me when I moved it to the other side. So I don't even have to remember that rule of switching the inequality. So these are both the exact same answer. X, you start from reading it usually from the variable. X is greater than 5 and X is greater than 5. So you get the same answer. But you can see you have less chance for error. You're going to deal with more positives doing it my way, more negatives doing it this other way. Okay. Now some books have gotten smarter and have seen that over the years finally, and are starting to do it as I would show it in class. But others in middle school teachers sometimes still leave it with the traditional way. I heard some students say that their middle school teacher said to always bring the variable to the left side. So it's already on the left side, they would leave it there. Okay, and if it was on the right side, they move the variable to the left side. For whatever reason, they'll teach to go ahead and always move the variable to the left side. I don't agree with it. Okay, I mean, you can still get the right answer. That's not the question. It's just chance for error. Okay, I want to decrease the chance for error. Okay, so now you can see both methods. And when you add in inequalities, it really saves you because you don't have to remember the rule of dividing by negative or multiplying by negative that I have to switch the inequality sign. If you do it my way, you're not going to ever have to remember that. You do it the traditional way, you will have to remember that every time. Okay, so this is also why I would not multiply the entire equation by -1 to change it to a positive, because then if I multiply this entire equation by -1 to change that -5x to a positive 5x, then I do have to remember that inequality rule of changing the inequality sign. If you just move it all the way across the first time, move that negative coefficient across the right side, make it positive, I don't have to remember about switching the inequality. It's already done for me in that step. Okay, so now you hopefully understand why I teach the way I teach as far as for solving for a variable.